Dear students, I am answering the last year's question paper, first term chemistry question paper 2025-26. It may be useful to you, the examination, next coming examination. Just follow up the question paper. See here, question number 1. Which is the functional group present in acetone? They ask the acetone, the functional group present in acetone. Acetone is a ketone. So here the options are given: hydroxyl, alkoxy, keto and aldehyde. So answer is keto, the first answer. It is a ketone. Acetone is a ketone. So the answer is keto. Next, second questions. Look there. Match the following they said: analgesic, antipyretics, antibiotics. Analgesic used for relieve pain, aspirin, such tablets. Analgesic used to relieve pain. So option A, third. Antipyretics, paracetamol, such tablets used to reduce the body temperature. So question B, first option, used for the reduce the body temperature. And C, antibiotics. Antibiotics is used to prevent the growth of infections or microorganisms. So second. So A third, B first, and C second. That is the answer. Next, third question. An alkane X with 4 carbon atoms X with 4 carbon atoms undergo thermal cracking to get the products Y and Z. X is an alkane. It has 4 carbon atoms. So we can write CH3, CH2, CH2, CH3. That is butane. Alkane with 4 carbon atoms. That is CH3, CH2, CH2, CH3, butane. 4 carbon atoms undergo thermal cracking to get the products Y and Z. To get the products Y plus Z. This is the question. An alkane X with 4 carbon atoms undergo thermal cracking to get the products Y and Z. Choose the correct options from the following. So here butane. Butane when undergoes thermal cracking, given in the textbook page number 39, look there. Butane when undergoes thermal cracking, you are getting propene and methane. Propene, CH3, CH, double bond, CH2 plus methane. But the options I cannot see there. Any of the, it is given in the page number textbook, page number 39. When butane undergo thermal cracking, it getting you the propene, CH3, single bond CH, double bond CH2 plus methane, CH4. Okay. Question number 4. L shell contains a maximum of 8 electrons. L shell. The question number 4th one. L shell contains maximum of 8 electrons. 8 electrons. And statement 2. L shell has 5 orbitals. L shell has 5 orbitals. 5 orbitals. This is the statement first one and second. So, L shell contains a maximum of 8 electrons and L shell has 5 orbitals. Which of the following options is true regarding these statements? They said statement 1 and 2 are correct. Statement 1 is correct, but statement 2 is not correct because L shell has 5 orbitals. It is not possible because L shell has 2 subshells, 2s and 2p. S has only 1 orbital and P has 3 orbitals. So, Even if you count also, you are getting only 4 orbitals, not the 5 orbitals. So it is wrong. Statement 1 is correct, but 2 is not correct. So that is the correct option. Statement 1 is correct, but 2 is not correct. Statement 1 is not correct, but 2 is correct. That wrong. D. Statement 1 and 2 are not correct. So the option is, correct option is second. Statement 1 is correct, but 2 is not correct. Look the question, fifth question. An aromatic hydrocarbon has 6 carbon atom and 6 hydrogen atoms in its molecule. Question A. Draw the structure of compound obtained when a hydrogen atom of this compound is replaced with an OH group. Write the name of this compound. So, question number 5. It is an aromatic hydrocarbon. Aromatic hydrocarbon, that is, you have to close with cyclic compound. Benzene ring we can draw. Double bond, single bond, double bond, single bond. This is benzene ring. Here C is here, and so one of the hydrogen atom CH around CH C6H6 C6H6. One of the hydrogen atom is removed and replaced with OH. So we can write like this OH. This is the structural formula of that compound. Write the name of this compound, draw the structure of compound, and obtained hydrogen atom of this compound is replaced with an OH group. Write the name of this compound. The name of the compound B is, this is phenol. So we can say phenol. The name of the compound is phenol. Now question number 6. Question number 6. Butane. What is meant by combustion? They said. Question is, textbook it is given in the definition. What is meant by combustion? When a hydrocarbon burns with the oxygen, they combine with oxygen in air to form carbon dioxide and water. So the combustion means when hydrocarbon burns, they combine with the oxygen in air to form carbon dioxide and water. So the product obtained when an hydrocarbon burns is carbon dioxide and water. These are the products, carbon dioxide and water. So what is the meaning of combustion? Combustion means burning of a hydrocarbon in air and react with oxygen to form carbon dioxide and water. So here butane burns in air, you are getting identify X and Y. They not require the balanced equation. So butane when burns, X and Y, they said X plus Y. So already we said carbon dioxide and water. So X is carbon dioxide and water. So the answer is carbon dioxide, CO2 and water. So when hydrocarbons burns in air, it reacts with oxygen to form carbon dioxide, water, and also heat, light. What are you getting that? Okay. Write the structural formula of X. What is the identify X and Y. Now, 7th question. Analyze the following. Propane. One hydrogen atom is replaced with an OH group. Seventh question, okay? Seventh question. So, seventh question A. Propane. One hydrogen atom is replaced with an OH group. Propane is this one, CH3, CH2, CH3. So hydrogen atom can be removed from here or also from here. If the hydrogen atom is removed from here, we can write CH3, CH2, CH2OH. One hydrogen atom is replaced with OH group. You can name it. IUPAC name is propane on ore. Okay. Hydrogen atom can be removed from here also. See, one option is that one, another chance. So we can write CH3, CH, OH, CH3. Propane 2 ore. So name of this compound is propane. So like that also we can, so only two options are there. First carbon also you can remove, from the second carbon also you can remove the hydrogen atom. Write the structural formula of X. And what is the IUPAC name? Propane 1 mole or propane 2 mole? You can write. And question number B, in that same question number B. One molecule of an aliphatic organic compound has 6 carbon atoms. It is identified as a saturated carboxylic acid. So, carboxylic acid, COOH is the group, function group is COOH. One molecule of an aliphatic organic compound with 6 carbon atom. So, we can write CH3, CH2, 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 1, 2, 3, 4, 5, COOH. So this is the formula of one molecule of an aliphatic compound of a 6 carbon atom is identified as saturated carboxylase. So write the structural formula of this compound. So this is the structural formula of the compound. 1, 2, 3, 4, 5, 6 carbon atoms. So hexanoic acid, you can say oic acid. Write the IUPAC name of this compound with this family with 5 carbon atoms. 5 carbon atoms, IUPAC, pentanoic acid. Oic acid, remove E and add oic acid. So, to name the carboxylic acids from pentane, remove E plus oic acid adds. So, we can say name of these 5 carbon atoms, pentane, pentanoic acid. The answer is pentanoic acid. Next question, question number 8. Write the structural formula of the given compound 2,2 dibromopropane. 2,2 dibromopropane. Propane. Question A. Propane means 3 carbon atom. 1, 2, 3. Number it. 1, 2, 3. So they said 2,2 dibromo. So we can write one Br here. Bromo means Br. So here also on Br, right? Okay. Now 2,2 dibromopropane, add hydrogen. Here 1 gone, remaining 3. 3 hydrogens. 3. Here also 3 hydrogen. Here no hydrogen. 4 also. 4 valence electrons are shared, so there is no hydrogen. So CH3 single bond CH3 CH3 dibro. This is the formula, the required formula. And write the structural formula, question B. Write the structure for propyne. So write 3 carbon atom. 1, 2, 3. I. So there is triple bond. Put anywhere triple bond here. Here or here. Anywhere you can put. And here 3 is gone, only 1 hydrogen. CH. And here no hydrogen because 3 and 4 is gone and here remaining CH3. So C3H4 molecular formula C3H4 propane. Sorry, propyne. Propyne C3, that is the structural formula of propyne. Now 9th question. Look. One ethane molecule is followed to react with allowed to react with the chlorine molecules. Write the structural formula of the product obtained. One ethyne molecule is allowed to react with the two chlorine atoms. Ethyne, CH, triple bond CH, ethyne, plus 2Cl2, two chlorine molecules. What you are getting here, it undergoes addition reaction. So add chlorine atoms here and here. The chlorine atoms are added here and here. So we can write C, single bond C, and here is a Cl, here is also Cl, one H, here Cl, here Cl, one H. So this is the product Cl, H, so ethyne undergoes addition reaction. Write the IUPAC name of this product set. So we can say here 1 and here 2. So IUPAC name is 1, 1, 1, 1, 2, 2, tetrachloroethane, 4 carbons, 4 chlorine. So we can write tetrachloroethane. The IUPAC name of this compound is 1, 1, 2, 2 tetrachloroethane. Tenth question, okay? A saturated aliphatic hydrocarbon molecule contains a total of 7 carbon atoms. There is a methyl group as branch at second carbon atom of this main chain. Question A. Draw the structure of this compound. Write the IUPAC name of this compound. Okay. Question number 10. A saturated aliphatic hydrocarbon molecule contains a total of 7 carbon atoms. So write 7 carbon atoms. So 1, 2, 3, 4, 5, 6, 7. Number it. 1, 2, 3, 4, 5, 6, 7. Now the name of the compound is total of 7 carbon. There is a methyl group as branch, as second carbon atom. Second carbon atom, there is a methyl group. So you write methyl group, CH3. That much only. Now, okay. Now put the hydrogen here 3, here 1, here 2, here 2, 2, here also 2, and here 3. 7 carbon atoms, so heptane. Second carbon atom, there is a methyl group. So name of this compound is 2-methyl. 2-methyl heptane. 2-methyl heptane. 11th question, okay. A polymer is used to coat the inner side of the cookware. Question A. Write the common name and IUPAC name of the polymer. So here common name is Teflon. The polymer used to coat the inner side of the cookware is Teflon. It is a common name, Teflon. And IUPAC name is tetrafluoro. Tetrafluoroethane. So and question B. Nylon 66 is a very useful polymer. What are the monomers of nylon 66? So answer, the monomers used to prepare the nylon 66 are adipic acid and hexamethyl diamine. Adipic acid. Sorry, adipic acid and hexamethyl diamine. The hexamethyl diamine. The monomers used to prepare nylon 66 are adipic acid and hexamethyl diamine. And write any one use of nylon 66. Nylon 66 are used to prepare fabrics, or nylon fabrics, nylon. Many uses are there. Can use brushes. Everything can write. Use fabrics using for preparing brushes or ropes. The things are there. Many uses are there. Okay. Now question number 12. There is a compound C. It is a compound given. Write the number of carbon atoms in the longest chain. Question number A. Write the number of carbon. If you take the chain like this 1, 2, 3, 4, and if you take the chain 1, 2, 3, 4, 5, if you take the chain like this, you are getting 1, 2, 3, 4, 5. So you have to select the longest chain is this one, and this will become the branches. This and this are become the branches. So longest chain 1, 2, 3, 4, 5. So the number of carbon atom is 5. Write the number of carbon atoms in the longest chain is 5. What is the position number of carbon atoms to which methyl groups are attached? Here 1, 2, 3, 4, 5. So 2 methyl groups, and question number we can write 3, 3. The position group is 2, 3, 3, and write the IUPAC name of this compound. See, 3, 3 dimethyl pentane, 5 carbons, so pentane. 3, 3 dimethyl pentane. Question number 13. A. Compounds CH3, CHO and CH3, CH2, CH3, CH2O. These are the two compounds given there. The question is, name the family to which these compounds belong. Question B, write the IUPAC name of these compounds. And question C, draw the structure of a compound having the same molecular formula of compound 2 but having another functional group. So here, name of this compound, this one, 2 carbon. So ethanol, we can write the name. Name of this IUPAC name is, first one, ethanol. And question 2, 3 carbon atoms, we can say propanol. Aldehyde group, sorry, these are all CHO, propanol. So the families to which it belongs is aldehyde. Aldehyde. Question number, a name of the family to which these compounds belong. Question A, that is aldehyde. Aldehyde. Question B, first one is ethanol, second one is propanol. Question C, belong to the draw the structure of a compound having the same molecular formula of compound 2 but having another functional group. So we can say here CH3 CO CH3 1 2 3 3 carbon, here 1 2 3, and hydrogen 3 5 6, here also 6, and O1 O1. So this is the compound answer. And B, pentane 2,1 and pentane 3,1 are a pair of isomers. So pentane 2,1. Write the structural formula of this compound. Pentane CH 5 carbon 1 2 3 4 5. Pentane 2 though. So number it 2,1. So you can write CO here. And here's H3, here H2, here H2, here H3. Next one, pentane 3,1. Put the here function group, and here CH3, CH2. This is the structural formula of pentane 2,1 and pentane 3,1. To which family of organic compounds do they belong? CO, answer is ketone. Ketone. Write the structural formula of a compound which has the same molecular formula of this compound but belong to another family. 5 carbons, so we can write aldehyde. So this always comes with the aldehyde. Question number C, aldehydes. So we can write 5, 1, 2, 3, 4, 5, last, an aldehyde group. And here write yes, this is the structural formula of the aldehyde. So the compound which is a different functional group having the same molecular formula is aldehydes. 1, 2, 3, 4, 5. So molecular formula is C5, C5, H3, 5, 7, 9, 10, H10, O. And here also 1, 2, 3, 4, 5, 3, 5, 5, 10, O. Molecular formula same. Look, question number 14. Starting from carbon monoxide, how will you prepare the following compounds? 1. Methanol and ethanoic acids. So starting from carbon monoxide, how will you prepare the following compounds? 1. Methanol and another one ethanoic acid. When when carbon monoxide, the answer is when carbon monoxide treated with hydrogen in presence of a catalyst at 573 degree Kelvin temperature, you would get methanol. This is the industrial production of methanol. When carbon monoxide treated with hydrogen in presence of a catalyst 573 degree Kelvin temperature, you would get methanol. When methanol is treated with carbon monoxide, CH3OH plus carbon monoxide in presence of catalyst, you will get ethanoic acid. So when carbon monoxide treated with hydrogen in presence of catalyst at 573 degree Kelvin, you will get methanol. When methanol is treated with carbon monoxide in presence of a catalyst, you will get ethanoic acid. Write the chemical equations of the reaction of formation of the compounds. Okay. Now 15th question, look. When an ethyl alcohol is treated with a carboxylic acid, in presence of concentrated sulfuric acid, a compound having a smell of pineapple is obtained. What is the general name of the product obtained? So when an acid and alcohol reacts, the compound we are getting is esters. So the first answer, we are getting the answers esters. When an acid and alcohol reacts, we are getting esters. One molecule of water is removed and we will get esters. What is the general name of this product obtained? Write the chemical equation of formation of this product. Okay. CH3 ethanoic acid, CH3COOH plus H2O alcohol, ethanol, CH2CH3. See, one molecule of water is removed from here and you are getting the product CH3 COO C CH2 CH3. This is the ester group COO. So name of this compound is ethyl ethanoate. Ethyl ethanoate. CH3 COO CH2 CH3. Ethyl ethanoate. The COO group is esters group. So when an acid and alcohol reacts, you are getting esters. Question number 16, look. Two statements regarding a shell are given below. The last electron of an atom fills into the shell with the principal quantum number n is equal to 3. This shell contains a total of 7 electrons. So 16th question, the last electron fills in an atom has the following quantum number, the last statement regarding a shell are given below. The last electron of an atom fills with the shell with the principal quantum number n is equal to 3. N is equal to 3, that is M shell. So write the electron configuration of this atom. Write question number 1. You can write 1s2, 2s2, 2p6, first shell, second shell, and third 3s2. And total they set 7 electrons, 3s and 3p5. Now 7 electrons are over. So 1s2, 2s2, 2p6, 3s2, 3p5. Write the electron configuration of this atom. Write the name of the subshell present in the shell with n is equal to 2. 2. The subshell is S and P, 2S and 2P. The subshells are 2S and 2P. How many orientations will be there for subshell with the L is equal to 1? It can be calculated by magnetic quantum number. Magnetic quantum M is equal to 2L plus 1. That is 2 into L is 1 plus 1. That is 3. So there is 3 orientations. How many orientations will be there for subshell with L is equal to 1? When L is equal to 1, there are 3 orientations. That is P subshell. P subshell has 3 orientations. Now question number 17. Look. PVC is widely used in a polymer. Starting from ethine, how will you prepare PVC? Starting from ethine, How will you prepare PVC? So answer is when ethane is treated with HCl, when treated with ethane, CH, triple bond CH, when it reacts with HCl, we are getting CH2 double bond CHCl. This is vinyl chloride. CH2 double bond CHCl is vinyl chloride. When CH2 double bond CHCl is polymerized n times CH2 double bond CHCl and polymerizer, you are getting polyvinyl chloride. Polyvinyl chloride. This is called PVC. Polyvinyl chloride. See, when vinyl chloride polymerizes, we are getting polyvinyl chloride or PVC. And question number 18. Molecular formula of a compound is C4H10O. Which are the families of organic compounds having this molecular formula? Question A. The molecular formula is C4H10O and compounds are alcohol. Families are alcohol and alkoxy, that is ether, alkoxy. Alcohol and alkoxy. Alcohol and alkoxy. Write the structural formula of a pair of functional isomers having this molecular formula. C4H10O, that is butane we say. So, pair of alcohols, pair of isomers we have tried. Write the structural formula of a pair of functional isomers. That means the functional groups are different. Write the structural formula of a pair of functional isomers having this molecular formula. Functional isomers group is different. We can write C4 means butane 1, 2, 3, 4, CH2OH. Alcohol, CH3, CH2, O, yes, CH3, CH2O, CH2, CH3. So these are the pair of functional isomers. And third question, question number C. Write the structural formula pair of position isomers having this molecular formula. Position isomers, same function group but different positions. Question number C. Same function group, position is different. So we can say 1 CH3, CH2, CH2, OH, butane 1,4. And another we can write CH3, yes, butane 2. Position isomers, position of function group is changed. Metamers having this molecular formula. CH3, CH2O, same can write CH3, metamers. Yes. What is the functional group that alkanes, alkyl groups are different. So this is the answer. Question B. 18th question B. C4H6 is the molecular form of a open chain hydrocarbon. Write the general formula of family to which this hydrocarbon belongs. C4H6. C4H6. C4H10, C4H8, C4H6. C4H10 alkanes, C4H8 alkenes, C4H6 double minus 2, double plus 2, double minus 2. That is Cn, general formula we can write CnH2n minus 2. In alkanes, CnH2n plus 2. In alkenes, CnH2n. In alkynes, this is alkyne, CnH2n minus 2. Write the possible structural formula of this hydrocarbon. C4. Only position of triple bond is changed. Position isomers, position of triple bond is changing. Write the possible structural formula of this compound. C triple bond. We can give here triple bond. 1, here no, here yes. Another one. Here give triple bonds. Here not, here not, here. Identify the type of isomerism exhibited by these compounds. Position isomers. Third one, position isomerism. Position isomerism. 4 hydrogen atoms are added to a molecular formula of this compound. Write the structural formula pair of chain isomers of this product. 4 hydrocarbons are added. D. 4 hydrocarbons are added, it will become butane. When 4 hydrocarbons are added, it will become butane, butane will become butane. CH3, CH2, CH2, CH3. So 4 hydrogen atom is added now. 3, 5, 10. Here H6, now H10. 4 hydrogen atoms are added, it becomes butane. Write the structural formula. Write the structural formula of a pair of chain isomers of this product. Chain isomers we can write. Yes. Okay. Carbon 1, 2, 3, 4, C4, H10. Here also 1, 2, 3, 4, C4, H10. This is butane. This is 2-methyl propane. 2-methyl propane. Yes, thank you.